All right, strap yourselves in, because today we're diving deep into India's Gaganyaan mission.
Oh, this is exciting stuff.
You bet it is. And you've sent over a ton of information on the TVD-1 test flight.
It's really quite a fascinating mission.
It is, and it's a major step towards India putting their own astronauts in space.
Definitely a big deal. And this specific test, what's really interesting is the focus on a critical safety system, the crew escape system, or CES.
Okay, the CES. And you've described this as like an insurance policy for the astronauts.
Yeah, think of it as an emergency escape pod, you know?
Got it, like if something goes wrong during launch.
Exactly, an emergency escape pod for the crew.
Makes sense.
Yeah, and the TVD-1 mission, it was really all about putting the CES to the test, you know, simulating a real in-flight abort, seeing how it performs under pressure.
Now, going through these documents you sent, it seems like this test vehicle, or TV, was a bit of a Frankenstein's monster, would you say?
You could say that, yeah, it was unique, a special build just for this mission.
Okay, so break it down for us.
So they took a modified Vikas engine.
That's one of India's, like, mainstays, right?
Yeah, you got it. A real workhorse in their rocket fleet, and they stacked the crew module and the CES right on top.
Ah.
The whole thing was massive.
I bet.
Nearly 35 meters tall, weighing a hefty 44 tons.
That's taller than a 10-story building.
It really is impressive.
Wow. And one thing I noticed, they use different types of fuel, right, for the main engine versus the CES?
Yeah, different needs, different fuel.
Why is that?
Well, the main engine, that uses N204 and UH25,
right,
which are great for sustained thrust.
Okay.
But the CES, it needs a quick burst of power to really yank the crew away if there's danger.
I can see that, yeah.
So for that, they went with specialized solid rocket motors.
Ah, makes sense. So it's like you need a different kind of engine for the quick getaway as opposed to the long haul.
Exactly, exactly. Different tools for different jobs.
Now, speaking of the CES, it's not just one giant rocket, is it?
Nope, you're right. It's actually multiple motors.
Oh, so there's a bunch of them in there?
There are 5 different solid rocket motors.
5.
That seems like a lot.
It does, doesn't it?
Yeah.
But each one has a very specific job during an abort.
Okay, so I guess it needs that many for different scenarios, or...
Yeah, think about it. The forces, the speed, the altitude, all different at various stages of launch.
Right, right.
So you need the right tool for the job depending on when and where that abort happens.
It's like a Swiss Army knife of escape options.
That's a great way to put it.
Uh-huh.
You've got it. For example, early in the launch,
Uh-huh.
you have what's called the HM, the high altitude escape motor.
Okay.
That's like your supercharged ejection seat built for high speeds and low altitudes.
Right.
Then you've got the LEM, the low altitude escape motor.
Okay.
This one kicks in later when the rocket is higher up, moving a bit slower.
So it's all about timing then, too.
Absolutely. Precise time.
Okay. But how do they make sure that, like, the crew module doesn't just, like, spin out of control after it's been blasted away? Great question.
From the rocket.
That's where these things called the pitch motors come in, the LPM and HPM.
Okay.
They make tiny adjustments to the module's orientation, making sure it's pointed the right way.
Ah, I see.
For a safe parachute deployment.
So they're like the little nudges to get it going in the right direction.
Precisely.
Okay.
Then you have the CJMERA, or the crew jettisoning motor.
Okay, another one.
This one comes in once the danger has passed.
Right.
It detaches the crew module from that whole escape system so it can head back down to Earth.
Got it. So 5 motors.
5 motors, that's right.
Each with a very specific role in making sure those astronauts get back home safe.
Exactly, even if things go wrong during launch.
And the documents mention some pretty incredible figures for the thrust generated by these motors, some exceeding 800 kN.
Oh, it's an incredible amount of power.
What's that like? Can you put that in perspective?
Think of the force it takes to launch a roller coaster uphill at top speed, you know?
Oh!
These motors generate many times that amount of thrust in a fraction of a second.
That's intense. It really shows how critical this escape system is.
It really is.
Yeah, keeping those astronauts safe.
Safety first.
Now, let's talk about the crew module itself, because it seems quite compact compared to, this massive launch vehicle we're talking about.
Yeah, the crew module, or CM, it's surprisingly small.
Oh.
Only about 3 meters in diameter and just under 3 meters tall.
Huh.
Think like a small room.
Okay, so pretty cramped quarters.
Yeah, pretty cozy in there.
Wow. And it's designed to be lightweight.
Right, lightweight, made mostly of aluminum.
Okay.
And for this particular test, they used a unique material to simulate the heat shield.
Yeah. The cork. I have to admit, I chuckled when I saw that in the reports.
It does sound a bit funny, doesn't it?
Cork? Really? For something so high-tech?
Right. But cork, it's incredibly effective as an insulator.
Ah, okay.
And surprisingly light. So for a test flight like this, it's a cost-effective way to gather data on the heat shield performance without using the actual expensive material.
That's pretty ingenious.
It is.
Repurposing, a common material to test something so critical.
Yeah, it's clever.
What about the inside of the crew module? What's it like in there?
All business in there.
I bet.
You've got your life support system, keeping the astronauts breathing, comfortable navigation system to guide them.
Of course.
And specially designed seats to withstand those extreme forces of launch and landing.
Yeah, I was imagining those seats are like what you'd see in like a fighter jet.
Yeah, built for impact.
Yeah, able to absorb a lot of shock.
Exactly.
Speaking of landing, they went for a splashdown in the Bay of Bengal, right?
They did.
Why a water landing instead of, touching down on solid ground?
Well, water landings are generally considered safer.
I could see that.
Especially for a test like this, provides a softer landing, and you have a larger target area.
Just in case there are any deviations from the plan.
You got it.
Plus, I'm sure the Indian Navy enjoyed having a front row seat for the recovery operation.
Oh, absolutely. They were a key part of it.
So it's quite the spectacle then.
It is.
You have this capsule bobbing in the ocean, and the Navy swoops in to retrieve it.
It's a testament to the complexity and precision involved in every stage of a space mission, even bringing it all back home.
Right, because it's not over till it's over.
Exactly.
So we've covered the test vehicle, the escape system, the crew module, and even this recovery operation.
A lot going on.
It's clear that a lot of thought went into every single aspect of this mission. But what were they actually trying to achieve with this TVD-1 test flight?
It was all about gathering data, proving concepts, really paving the way for future human spaceflight endeavors for India.
So a lot of it was about de-risking the mission, making sure the technology, the procedures are ready for the real deal, sending humans into space.
Exactly. They needed to validate how this test vehicle performs, ensure that crew escape system could, reliably whisk the crew to safety.
Right, if needed.
And collect that valuable data on how the crew module performs during descent and splashdown.
It's like this giant puzzle where every piece has to fit perfectly.
It is.
And this was about making sure all those pieces are in the right place, working together.
And that's precisely why missions like the TVD-1 are so crucial. They provide that real-world data and experience. They need to fine-tune the technology, the procedures, ensuring the safety and success of future crewed missions.
And it's fascinating to see how India is approaching this, taking this methodical, data-driven approach to human spaceflight.
It is fascinating, isn't it?
Yeah, but beyond all the technical stuff, I'm also curious about the people behind it all.
Of course.
What can you tell us about the team at ISRO who actually made this happen?
The team at ISRO is truly remarkable. A blend of brilliant engineers, scientists, technicians, support staff, all working tirelessly towards this common goal,
Yeah. Their dedication and passion, it's evident in every single detail of this mission.
It's always inspiring to see that human element behind these huge scientific endeavors reminds us that it's not just about the technology, it's about the people, the talent, the dedication.
It really is about the people, the ones who push the boundaries of what's possible.
Right, working together.
Absolutely. A testament to human ingenuity, that collaboration, and that unwavering spirit of exploration.
Couldn't agree more.
Yeah.
Well, we've covered a lot of ground here, from the test vehicle to that intricate escape system.
Lots of moving parts.
Definitely a lot going on there.
And we've talked about the crew module and the critical role of the recovery operation.
But I'm really eager to delve deeper into the specific objectives of this TVD-1 mission.
Me too. I think that would be really interesting.
What kind of data were they hoping to collect, and what does success actually look like?
Yeah, let's unpack those specific details, get into the nitty-gritty of what ISRO was really aiming for.
Okay, sounds good. Let's do it.
Let's do it. And we'll be right back after a quick break to get into those mission objectives.
Sounds great.
Stay with us.
Okay. Welcome back. All right, let's get into the specifics of what ISRO was hoping to achieve with each stage of this TVD-1 mission.
Okay, sounds good.
This wasn't just a joyride. It was a meticulously planned experiment
Right.
with very clear objectives.
So let's start with the test vehicle itself.
Okay.
What were they hoping to learn about its performance?
So for the test vehicle, the primary objective was to validate the performance of all its subsystems under actual flight conditions.
Okay.
This includes everything, the propulsion system,
Right.
navigation and control systems.
So it was like a comprehensive checkup, making sure everything was working as expected.
Exactly, a full checkup.
Under the stress of launch and flight.
Under pressure.
Yeah, exactly.
Remember, this was a modified design.
Right, with a crew module and CES stacked on top.
Right, and they needed to ensure those modifications didn't negatively impact the vehicle's performance.
Makes sense. They're essentially building a foundation for future human missions. So any surprises at this stage that could have big consequences down the line.
Absolutely, it's all about laying that groundwork.
Now, what about the star of the show, the crew escape system? What were the key objectives there?
Okay, so the CES had two main objectives.
Right.
First, demonstrate its ability to separate cleanly from the launch vehicle at supersonic speeds.
Okay, so imagine the forces involved
Oh, yeah.
in pulling that crew module away from a rocket traveling faster than the speed of sound.
It's mind-boggling.
They can barely fathom the physics of that maneuver.
Incredibly complex.
And dangerous, I would imagine.
It is very much so.
And what was the second objective?
The second objective for the CES was to prove that it could ensure the safe recovery of the crew module,
Okay.
meaning separating at the right time,
Right.
orienting the module correctly, and making sure it lands within the designated area.
So they weren't just testing the physical separation. They were validating that whole sequence of events leading to a safe landing for the crew module.
The whole shebang.
It's all connected.
It is absolutely interconnected, looking at everything. The timing of the motor firings,
Right.
the stability of the module during separation, and how effective that parachute deployment system is.
So many things to consider.
A lot of factors at play.
Now, I'm curious about the data they were collecting to actually measure success here. What were the key performance indicators for each of these objectives?
So for the test vehicle, they were monitoring a whole array of parameters.
Gotcha.
Engine performance, trajectory accuracy, structural integrity under those aerodynamic loads.
Wow, that's a lot.
The list goes on. They had sensors everywhere, feeding data back to mission control in real time.
It's like they were giving the vehicle a full body scan,
I like that, a full body scan.
looking for any signs of stress or anything out of the ordinary.
They needed to know exactly how the vehicle was performing at every single moment of that flight to ensure everything was within those expected parameters.
No room for error.
Very little room for error when it comes to spaceflight.
What about for the crew escape system? What were they focusing on there?
For the True Escape system, the primary focus was on the separation dynamics.
Okay.
They were measuring the acceleration forces experienced by the crew module, how long it took to achieve a safe distance from the launch vehicle,
Okay.
and how stable the module remained during that escape maneuver.
So it's about speed, precision, and stability.
You got it. Crucial factors when you're trying to escape a potential disaster.
Right, because every second counts in that scenario.
Every millisecond.
Wow.
Those measurements, they would tell them if the escape motors provided enough thrust,
Right.
if the separation mechanisms worked flawlessly, and if the crew module's movements were within the limits a human body could tolerate.
So they were thinking about the human factor even at this stage.
Always, human safety is paramount.
It's amazing how much data they can capture during a test like this.
Technology has come a long way.
What about the crew module itself? What were the key data points they were looking at for its performance?
For the crew module, primarily interested in data related to its deceleration and stability during descent.
Okay.
They were measuring things like the timing of the parachute deployment sequence,
Right.
the descent rates, how aerodynamically stable it was, and the impact forces experienced during splashdown.
So basically analyzing how effectively the module slowed down,
That's right.
how smoothly it glided through the air, and how gently it landed in the water.
All about ensuring a safe and comfortable ride for those astronauts.
Absolutely. Got to make sure they have a smooth landing.
Exactly. Smooth return.
What else were they monitoring?
Well, they were also monitoring the performance of the environmental control systems inside the module.
Okay, so like temperature, pressure, oxygen levels, that sort of thing.
Exactly. All those vital signs.
To make sure the module could maintain a habitable environment for the crew.
Even during the intense conditions of re-entry and descent.
Right, when things are really heating up.
Literally heating up.
It's incredible to think about all these different systems working together to ensure a successful mission.
It's a symphony of science and engineering.
It really is.
All orchestrated to perfection.
Now, we've talked about the data they were collecting, but let's zoom out a little bit.
Okay.
What are the broader implications of this TVD-1 test flight
Right.
for India's human spaceflight ambitions?
Well, the TVD-1 test flight, it was a resounding success.
Right.
Demonstrating India's commitment and capability to develop a robust human spaceflight program.
I bet they were thrilled.
Absolutely. This is a huge leap forward in their journey towards sending their own astronauts into space.
Putting them in a very select group of nations with that capability.
An elite club.
The success must have a ripple effect, right?
It does.
Beyond just the space program.
Yeah.
I imagine it's a source of national pride.
Oh, definitely.
And inspiration for the entire country.
Absolutely. Showcases India's technological prowess on the global stage. Yeah.
Inspires future generations of scientists, engineers, dreamers.
Right. You see this and you think anything is possible.
Exactly.
And it has the potential to stimulate technological advancements in other sectors too, right?
It does. That knowledge gained from space exploration often finds applications in everyday life.
It's amazing how one mission can have such a wide-reaching impact.
It really is. It goes beyond just rockets and astronauts.
It's about pushing the boundaries of human ingenuity.
Inspiring the world.
And let's not forget the geopolitical implications.
Oh, right.
India's success in human spaceflight, that strengthens their position as a major player on the global stage.
It does.
Not just in science and technology, but also in terms of international collaborations and partnerships.
Absolutely. Opens up so many doors.
It's like a domino effect.
Yeah.
One achievement leading to another.
Creating new opportunities.
A fascinating story unfolding before our eyes.
And we're just at the beginning. This TVD-1 mission, it was a crucial step. Right. Setting the stage for even more ambitious goals.
Paving the way.
I'm excited to see what the future holds for India's space program, but before we dive into that,
Okay.
there's another aspect of the TVD-1 mission I'd like to explore further.
Okay.
The recovery operation.
Okay.
It's often overlooked,
Yeah.
but it's a crucial part of any space mission,
It is bringing that crew module back safely
especially one involving a splashdown.
and recovering all that valuable data.
Right, because it's just as important as launching it in the first place.
Exactly. You can't just leave it out there.
And when you're dealing with a landing in the open ocean, that adds a whole other layer of complexity.
Oh, it does. A whole other challenge.
I can only imagine the logistical challenges.
It's a massive undertaking.
It's like finding a needle in a haystack. But the haystack is a vast expanse of water,
That's a great analogy.
and the needle is this relatively small capsule.
A tiny speck in a vast ocean.
Exactly.
And it's not just about finding it, it's about retrieving it safely without damaging the module.
Right.
And making sure you don't lose any of that precious data it contains.
So how do they pull that off?
Well, let's take a closer look at that recovery operation
Okay.
and the role of the Indian Navy in this mission, because they played a crucial part.
Sounds good to me.
All right, let's dive into the details of this underwater adventure.
So we're talking about finding this capsule after splashdown.
Yep, in the Bay of Bengal.
Sounds like a tough job.
Oh, it is. But the Indian Navy, they were ready for it.
Okay, good.
They have a whole plan and some pretty impressive technology to help them.
So walk me through it. What's the first step after that splashdown?
Okay, so picture a carefully coordinated search party.
Right.
The Navy, they deploy a fleet of ships
Wow, a whole fleet.
equipped with, sophisticated tracking systems.
So they're not just like looking out with binoculars hoping to spot it.
No binoculars here.
Okay.
We're talking radar, sonar, even aircraft,
Wow, that's high tech.
all to pinpoint that capsule's location.
Sounds intense.
It is like a high-stakes game of hide and seek, but in the ocean.
Yeah, with a very valuable piece of equipment.
Exactly. And to help with the search, the crew module itself, it's equipped with radio beacons,
Oh,
sending out signals.
smart.
Plus, it releases these dye markers into the water, creating a visible plume.
Oh, I see.
Helps those search teams zero in on the location.
So multiple layers of redundancy, just in case.
Exactly. They don't want to lose track of this thing.
Makes sense.
But once they've found it,
Yeah, then what? How do they actually get it out of the water?
right, that's where the divers come in.
Ah, okay.
They're specially trained to operate in these conditions.
I bet.
They approach that floating capsule carefully.
Right.
Their job is to secure it and attach it to a recovery crane.
Which is on board one of the ships.
That's right, one of those ships in the fleet.
I can only imagine that's got to be a delicate operation, right?
Oh, very delicate.
The currents, the waves.
Yeah, the ocean is unpredictable.
Requires a high level of skill
And
for those divers.
once that capsule is securely attached, the crane slowly lifts it out of the water
Okay.
onto the deck of the ship.
Wow, it's amazing how every stage of this mission, even this recovery,
It's all connected.
involves such careful planning
It does.
and coordination, a real team effort.
A testament to the professionalism of the Indian Navy
Absolutely.
and their commitment to supporting this space program.
Yeah, working together to make it happen.
But it doesn't stop there.
Oh,
Once the capsule is safe on board, they got to secure any hazardous materials,
right, of course.
download all that data from the onboard recorders,
That's the important stuff.
and then carefully transport the module back to ISRO for further analysis.
So it's a whole chain of events,
A relay race.
each step just as crucial as the last.
Can't drop the baton.
So the TVD-1 mission was a success.
A resounding success.
The recovery went smoothly, and ISRO now has all this data.
Mountains of data.
What's next for India's human spaceflight program? What are they aiming for now?
Well, the next big milestone is the uncrewed Gaganyaan orbital mission.
Okay, so still no astronauts yet.
Not yet. This is the dress rehearsal.
Got it.
They'll send a fully equipped crew module into orbit around Earth, but without any astronauts on board.
Okay, so testing everything out one last time before the real deal.
Exactly. It's all about reducing risk.
They'll be watching everything closely, I imagine.
Oh, yeah. Every system, life support, radiation shielding.
Making sure it can all function properly in space.
Making sure that spacecraft can maintain a stable orbit for an extended period.
Can't imagine the tension at mission control during that flight.
A lot of nail biting, that's for sure.
Because everything needs to be perfect before they even think about putting humans on board.
Human safety is the top priority.
So if this mission is successful,
Fingers crossed.
it paves the way for India's first crewed mission into space.
That's the goal.
That's going to be
This
huge.
historic moment.
Do we have any idea when that might happen?
ISRO hasn't announced a specific date yet, but they're aiming for sometime in the next few years.
Right.
The plan is to send a 3-person crew into orbit
Wow, 3 astronauts.
for several days.
I can't wait to see it.
It'll be a major achievement.
Not just for India, but for the whole global space community.
Absolutely. Everyone will be watching.
And what will those astronauts be doing up there?
Well, they'll be conducting a variety of experiments, observations.
Okay.
Could be anything from studying the effects of microgravity on the human body
Right. Fascinating stuff.
to taking incredible images of Earth from space.
I bet those will be stunning.
Oh, yeah. Breathtaking views.
It's incredible to think that we're this close to seeing India join that group of spacefaring nations.
It's a testament to their hard work and dedication.
Their journey has been marked by determination, innovation, pushing those boundaries.
And they're achieving all of this independently,
That's really impressive.
relying on their own ingenuity and resources.
Wow, a true testament to their capabilities.
They're carving their own path in space exploration.
It's inspiring, reminds us that the spirit of exploration, it doesn't have any limits.
There are no boundaries when it comes to human curiosity.
So what's next for them after this crewed mission? What's on the horizon?
Well, the sky's the limit, right?
Haha, good one.
Their long-term vision includes developing a space station
Wow, ambitious.
and potentially even sending astronauts to the moon.
That would be incredible.
Ambitious goals, but given their track record,
Yeah, they've proven they can do it.
I wouldn't bet against them.
It's going to be an exciting journey to follow.
It really is.
But before we wrap up,
Yeah.
I want to touch on something we mentioned earlier, how India's space program has these implications that go way beyond just science and technology.
Right. It affects all of society.
Their achievements in space, they inspire young people,
The next generation of scientists and engineers.
drive technological advancements in other fields,
Absolutely. It's a ripple effect.
and of course, boost national pride.
A source of unity and inspiration.
It's a testament to the power of human ambition
The drive to explore the unknown.
and a reminder that anything is possible
As long as we set our minds to it,
and work together to achieve that common goal.
collaboration is key.
Well, this deep dive has been a fascinating journey.
It has.
We've explored this TVD-1 test flight in detail, the complex recovery operation,
A lot of moving parts.
and talked about the exciting future that lies ahead for India's human spaceflight program.
A bright future indeed.
It's been an incredible story of scientific endeavor, technological innovation, and that unwavering human spirit of exploration.
It's been a pleasure to share this journey with you.
Likewise.
And I hope our listeners are just as inspired as we are by India's achievements in space.
And on that note, we've reached the end of our deep dive into India's Gaganyaan mission.
Time flies when you're talking about space.
Keep looking up, keep exploring, and never stop asking questions.
Those are words to live by.
Until next time, farewell.
Farewell.